Welcome to our channel. Today we find the area of a quadrilateral ABCD with the sides are known 9 meter, 40 meter, 28 meter and 15 meters, and you are given a clue that is the angle between the first two sides is 90. First let's make up a diagram with the given measurements. First two sides include angle is 90. Let me draw the first two sides first. Here I draw 9 meter. That is the first side, and second side is 40. So angle between these two is given 90 degrees. This is 40. Let me complete the figure. The third side is 28. Okay, and the fourth side is 15. 28 meter, 15 meter. You have to find the whole area of the quadrilateral. We know a diagonal divides the whole figure into two triangles. Okay, when you find the area of the first triangle and second triangle together, you get the area of the quadrilateral, that is ABCD. But to get the area of the first triangle, we have only two sides, but the third side, that is the diagonal of the quadrilateral, is not known. But we know this is the right angle triangle, that is ABC. So AC is the hypotenuse. So in this triangle, I can find AC. AC square is equal to AB square plus BC square. Why? Because Pythagoras. By Pythagoras, we can find the hypotenuse of any right angle triangle. Here we have AB for 9 square and BC for 40 square. So 81 plus 1600, together 1681, which is the square on the hypotenuse. So AC is the root of 1681, that is 41 meter. So we have the third side 41 meter. Now we can find the area of the first triangle. We have 9, 40, 41. And the second triangle also 15, 41, 28. We can find the area of the two. Now, I find the area of the first triangle, that is area of triangle is ABC triangle. ABC. We know the area of the right angle triangle can be found out by half the product of legs. Since it is the base, it is the perpendicular on the base. So half base into height gives the area. We don't want the Heron formula here. So here I use half B into H. In this triangle, the base is 9, whereas the height is 40. So 220 times, and it gives 180 meter square. Clear? Now I find the area of the second triangle, that is ACD. Since it is a scalar triangle, I must go for Heron formula. So area of the second triangle ACD, I am calculating now. So I must know what is S, the semi perimeter, which is the sum of all the three sides, that is 41 plus 28 plus 15 by 2. Okay. This gives the semi perimeter of these sides. The sum of these two is 15 plus 28 plus 41 is 84 by 2, which gives 42. Now I can use the Heron formula. Therefore, area is equal to root S of S minus A, S minus B and S minus C. S 42 of 42 minus 41 of 42 minus 28 of 42 minus 15. Okay. So it's under root 42 into difference of these two 1 into 42 minus 28 14 into Therefore, let me split all the numbers into its factors. That is 42 is 2 into 3 into 7 into 1 I don't write, and whereas for 14 2 into 7, for 27 3 into 3 into 3, it is 3 cube. So we have a pair of 2's, that is 2 square, 3 4 times, so 3 power 4, and 7 square. So its square root 2 into 3 square into 7. So finally we get 126 meter square. Okay, and area of the triangle, first one is 180 and second triangle is 126. Finally we can write area of quadrilateral ABCD, which is triangle ABC plus triangle ACD, which is, the first one is 180 meter square and the latter is 126. Together we get 306 meter square. Okay, so by using the concept of Pythagoras, we found the diagonal. By using diagonal, we find the area of the first triangle. That is, by using the Heron formula, we find the area of the second triangle. Together it gives the area of the quadrilateral on the whole. Let's see one more question. Now in this question we have a trapezium. We know the trapezium is a quadrilateral where a pair of sides are parallel. The measure of parallel sides are given 25 and 10 and non-parallel sides 14 and 13. Let me draw the diagram with the given measurements. I draw the parallel sides first. 10 meter and the other is 25 meter. Okay, let me complete the figure. Right, this let me name it as ABCD. So here ABCD is a parallel. Here ABCD is a trapezium and these two are parallel, these two are non-parallel sides. One is 13, other is 14 meters. Here also we want a diagonal. But by drawing diagonal, as in the previous question, it may not help us. So I draw a parallel line to AD through C point. This is my construction. See the dotted line. This is my construction. That is CE is a construction. So that CE is parallel to AD. So these two are parallel and these two are parallel. So this is a parallelogram. The one is a parallelogram and 2 is a triangle. And in a parallelogram, the opposite sides are equal. So I also mark this as 13 meters. And here this is 10 meter. This is opposite to AE. So AE also 10 meters. But on the whole, we have AB 25 meter. So this part, that is EB, is 15 meter. Okay. So in this triangle, we have all the measurements 13, 14, 15. By using Heron formula, we can find the area of the triangle first. Let me find this. So what is given here? The same. And what is constructed here? CE parallel to AD. So by doing so, we got CE measurement, which is equal to AD measurements, that is 13 meter. And also in this parallelogram, AE is equal to CD, which is equal to 10 meter. Therefore, the EB is the difference of the total measurements and this 10. So BE is equal to AB minus AE. AB, which is, we know that is 25, and AE is got 10. So this is 15 meters. These are the measurements we have. Now let me calculate the area of the triangle first by using Heron formula. So area of triangle, what is the triangle name? CEB. CEB. This I am calculating first. Okay. So I want S, that is 13 plus 14 plus 15 by 2, which gives 42 by 2, that is 21. So S is 21. So area is equal to, we know the formula, Heron formula, root of S of S minus A, S minus B, S minus C, which is S is 21 of 21 minus 13, 21 minus 14 and 21 minus 15, which are the sides of the triangle CED. So we remain with 21 into 21 minus 13, 8 into 21 minus 14, 7, 21 minus 15, 6. Okay. Let me write all the numbers into its factors. For 21, we write 3 into 7. For 8, it is 2 cube. For 7, for 6, 2 into 3. So finally we have a pair of 3's, that is 3 square, and a pair of 7's, that is 7 square, and 2 4 times, so 2 power 4, root. Its root is the square area of the triangle, that is 3 into 7 into 2 square, that is 3 into 7 into 4, that is 84 meters square. So we got the area of the triangle. But to get the area of the parallelogram, we know the area of the parallelogram is equal to BH, base and altitude, or altitude. This is the height of the parallelogram, that is CF. So CF is the height of the parallelogram. Of course you can draw CF here also. By drawing here you understand the area of the triangle can be obtained by half base into height. So half base into height is the area, and also Heron formula also gives the area. Already we got the Heron form area. So it is equal to half BH, of 15 into CF. When you find CF, this CF helps us to find the area of the triangle, that is H. Okay. Let me equate here. Therefore, half BH is equal to this 84 meters square. That is half into what is the base now? 15. 15 is the base of the triangle. We have to find the altitude on this base. 84 meters square. So H is equal to 84 into 2 by 15. 5 times 3, 28 times, which is 56 by 5. I get 11.2 meter. So we got the altitude, that is 11.2 meter. Now I can find the area of the parallelogram, base into height. Now area of parallelogram is equal to BH, in which base is 10 and altitude is 11.2. 10 into 11.2, which is 112 meter square. Clear? The sum of parallelogram and triangle together area of the quadrilateral. Finally we conclude, therefore area of trapezium is equal to 84, which is the area of the triangle, and area of the parallelogram 112 meters square. Together we get 196 meters square. Okay, we may not depend always on the diagonal of the quadrilateral. This is a different question. Trapezium question is different. In trapezium always you have to split trapezium always split into a parallelogram and triangle. This combination gives the area of the triangle always. We see some more questions in our next video. Thank you.